Generally, we resolve into factors the quadratic expression and expressed in the form of ax plus b into cx plus d equal to 0. Then from that we conclude either factor will be 0. From that we get the values of x. If we change the symbol of the imaginary part, here it is plus iy. If we change minus iy, then that is denoted by the symbol z bar, which is x minus iy. Things already I have discussed. If I call those, or if I take that as group A, then I start group B or serially B. Now I am going to discuss complex number. Any number which is expressed in the form x plus iy, any number which is expressed in the form x plus iy, where x, y both are real, is called a complex number. Also, it is represented by the order pair xy and represented by denoted by z. Therefore, z is equal to x plus iy. The number which can be expressed in the form x plus iy also by the order pair xy, where xy both are real, is called complex number. Now let me discuss why we need complex number. To discuss that, we have to go back to solve quadratic equations. Also, we get this while we solve cubic equation or equations of higher degree. We take quadratic equation. Example, if we solve these two equations, what we get? For the first one, generally we resolve into factors the quadratic expression and expressed in the form of ax plus b into cx plus d equal to 0. Then from that we conclude either factor will be 0. From that we get the values of x. I solve this one. I write here directly, not showing the detailed steps. The values are 1, 2. Now, if I solve this, the values will be x equal to plus minus 3. I have not shown here detailed steps. I suggest students like this. If you get an equation of the form x square minus p square equal to 0, then next step will be x square equal to p square. From that we suggest to write direct values x equal to plus minus p. Detailed steps you can show. Thus, while we solve such types of equations, also there is another type where the quadratic expression cannot be resolved. In that case, we apply Sridharacharya formula, and that can be written by using or by forming a square form involving x is equal to some constant. From that, like this step, or we use Sridharacharya formula, and in that case, if the equation can be written in this form where a non-zero, then by using Sridharacharya formula we get minus b plus minus root over b square minus 4ac by 2a. And in some cases we see b square minus 4ac may be less than 0, then the problem occurs. Now I take few more examples like this. X square plus 9 is equal to 0. Now from that we can write, using this concept, x square is equal to minus 9. That means 3 square into I square. As already we have defined, minus 1 is equal to I square, then I can write x square equal to this. From that, x equal to plus minus 3i. Thus, in such example, also I take another example. X square plus 2x plus 3 equal to 0. If we solve this equation with following conventional method, then we can write therefore, if we consider general case of solving ax square plus bx plus c equal to 0 where a non-zero, then we get real roots like this, as well as roots in this form. Since I is there, therefore this is imaginary and this is complex of the form x plus I. Therefore, for solving quadratic equation of general form, we must have the idea of square root of negative number. In such cases, imaginary numbers occur. Therefore, a complex number is expressed by x plus iy or the order pair xy, and it is denoted by z. X, y x is the real part, which is denoted by the symbol y is the imaginary part, denoted by the symbol when y equal to 0, z is real. When x equal to 0, z is purely imaginary. Otherwise, we name complex number. Now, there is another term complex conjugate or conjugate complex number of z. If we change the symbol of the imaginary part, here it is plus iy. If we change minus iy, then that is denoted by the symbol z bar, which is x minus iy. We call x plus iy and x minus iy are conjugate. Sometimes complementary term is also used. Complex numbers. If x plus iy be denoted by z, then its complex conjugate will be z bar x minus iy. Following this law, complex conjugate of z bar will be therefore conjugate of a complex number is the complex number itself. Therefore, z double bar is equal to z. Now, the new terms modulus and amplitude. First of all, modulus of z. Symbol is and that is equal to square root of root over x square plus y square. Actually, in the next episode, I shall discuss representation of complex number in the or on the complex plane or z plane or organ plane, where we shall explain why modulus of z is root over x square plus y square. Then we take an example. Find modulus of 3 plus 4i is 5. Then the term amplitude if the complex number is x plus iy, then amplitude if theta be the amplitude, then real part x equal to r cos theta, imaginary part y is r sin theta. Therefore, theta can be determined. Therefore, tan theta is equal to y by x roughly. Therefore, theta equal to tan inverse y by x. Actually, if we know the actual value of x and y, then we can determine the position of the complex number on the organ plane or z plane. Accordingly, we shall find theta, amplitude. This matter will be discussed in the next episode. Thank you.